Basically, I'm sure like as part of your day-to-day work, you would be interacting with software development teams, right? Or in some way or other, may not be directly, but to some extent, right? They come to us with requirements, right? So some of the concepts that from that word are like, you'll be hearing this a lot, right? Nowadays, CI/CD, Agile, etc., etc. Basically, what happens is like design, develop, maintain, review, which again leads to design cycle. Right? This is a kind of cycle that goes on and on. There's a client who gives you a requirement to build something. Right? I'm talking for now from the automation, from the software development point of view. Later, I'll connect this to the networking example. Right? So we take this requirement. Let's say I want to build a banking application. Right? So there's a banking domain expert who gives me requirements saying these are the features that my application should have. Customer should be able to once he comes to the bank, opens an account, he'll get his online credentials. Then he should be able to download the application from one of the Play Stores. He should be able to register himself. Then his login details should get linked to his account details. Once that is done, he should be able to manage his own account, right? Check the balance, make the transfers, etc., from this thing. So we take these requirements. There's a architect who is sitting there. He designs how to build this system, like what are the building blocks that are going to be there. There is going to be a login module. There's going to be a home screen, etc., and then he gives that design to developers, and they develop that application. And they show it to the customer likes it, he deploys it in production, they start using it, it gets into maintenance mode, which means, let's say there is some issue, right, or some enhancement is required. We do that change and release the next version of it, right? Now, let's say after using for some time, they realized, oh, okay, right now, only basic login is supported. Now, we want mobile number and OTP-based authentication, right? That becomes a new requirement, right? They give a new requirement. Now, to implement this new requirement, again, we need to get into design cycle, right? The architect has to come in, he will design it, like what is the best way? Because in the process of implementing this new feature, he should not break the existing stuff, right? So it goes through this entire process again: designing, developing, maintaining, review, and again, right? So this is what is this is how software applications are developed. Now, once these software applications are developed, as I said, like there's a V 1.1, right? Version 1.1. After some time, people start using, they need a new version. So we come up with V 1.2. This goes on, right? Till some time. Till then we come up with some major changes, some architectural changes or something. Release V.2, V2.0, version 2.0, and so on, right? So there is a need. Now, when you're writing a lot of code, when you're releasing a lot of new versions, now you can very well relate to this, the networking concepts also, right? Like Cisco comes up with operating systems for each of their devices. There are versions associated with that. So this is pretty much, you can relate to the same concept as well. So there is a versioning system which is required, version control system. Right? So whenever you're writing a lot of code, there are a lot of versions which are getting generated. We need version control systems because we should be able to properly manage these versions, right? Why? Let's say customer 1 is on V 1.1. Now, he doesn't want to spend money. He is happy with the 1.1 features. He continues to use 1.1. We build this, we give it to, let's say, customer 5, and we go back to customer 1 and say, we have now a very new feature, which is 2.0. We have a lot of new features. Would you like to upgrade? We will give it a certain cost. This guy says, no, I don't want to spend any extra amount now. I'm happy with the 1.1 features. You need to continue supporting me. Right? Now, let's say there is a defect in 1.1. Now, this is a totally different version. We are like well ahead. We are at 2.0. We need to go back to 1.1, fix that defect. Right? So all this should be managed properly through some system called as version control systems. Right? We have the most popular version control system nowadays, which is very popularly used, called Git. Okay. Now, why I am introducing this is, like, let's say we have Cisco devices, right? Routers, switches, firewalls, right? Now, these are all interlinked, right? There is something that we do here which impacts this, something here which impacts something here, right? We apply some policies here which are applied to routers, switches, etc., etc. So all this we can achieve through APIs. Nowadays, Cisco or other devices as well, for that matter, are exposing everything that is there on the devices in the form of APIs, application programming interfaces. Right? It simply means that a way for two software programs to talk to each other. They talk via API. Right? Now, you use this API, or routers expose an API. You use this API, write some code, and use this API, write some code, right? Use this API, write some code. Now, in the process, you are ending up with a code. As I'm going to show a demo, right? We have written a script where we have a bunch of IP addresses, right? These IP addresses can be servers or switches or routers, right? We take this, we give this in a CSV or Google Sheet. Then our script will ping each of, it takes each of these IP addresses and it pings them. If ping is working, it says, yes, so and so, it is working fine. If ping fails, it goes and updates one sheet saying ping has failed. So now I'm trying trace route. Right? Then it checks the trace route, whatever is the number of hops. Let's say the maximum number of hops is 30. At hop 10, after hop 10, it starts failing. Right? It picks up this last hop. There is some IP address, right? The last hop IP address. It extracts this IP address, goes to internet, to a database called as Whois database, checks who this IP address belongs to, and then updates the sheet. And now it has failed at this step. So it goes to ServiceNow and creates an incident. And then it goes to Grafana and creates a dashboard with what happened to each of the IP addresses. IP address 1, IP1 success, IP2 failure. In that failure also where it has failed. It has failed in IP ping, it has failed in trace route, etc., etc. Right? So this is a sample kind of integrated application that you might be expected to build in future as a new gen network engineers. Right? So one thing that highlights the importance of why you should learn programming, why you should be familiar with all these concepts of APIs and automation. And the other thing is, whatever I said, it's a bunch of code. Right now, I have written v1.1. If I want to make any changes, I've already checked it into my, let's say, GitLab account, either on-premise or on cloud. I'll not be disturbing the existing ones. I'll create a new version, 1.2, and make enhancement here. Right? So we should know about this. Now, this is the process of CI/CD. Right? You have a version control system which is lying today. Right? Today, I worked on some feature here. Immediately, I will push my code here. This is my repository, code repository, right? Which is like GitLab, which is sitting there. I make some changes here today. Immediately, I'll push these changes. I should be able to generate a build, working copy. Working build. So that the change which I made here is already available to some customer who needs it, right? Tomorrow, I make some other change. Right? Immediately, I should be able to push it to my repository and generate a build. So that is the meaning of continuous integration and continuous delivery or deployment. At any point of time, I should be able to push my latest changes to some code repository and be able to generate. Now, how it is used in the networking world, right? How CI/CD is used in the networking world. It may not be so much, but let's say you have a bunch of devices, right? Each of them have their configs, running configs, right? So initially, you will use some tool like Ansible or something. You will create a backup of all these configs, right? There's a backup of your entire network devices running configs on so-and-so date. Now, where do you store this backup? As of now, where do you store these backups? Anyone?
Where do you store your backups, guys? Suppose you configure something, where do you store your backups?
A storage server, so maybe Linux, yeah.
Storage server, right? So what we are proposing, we are proposing is do not use any storage server, use GitLab. Right? So that tomorrow I need to, some configuration change is there. So there's a daily backup script which runs. So there's a backup which is created, which is again pushed to GitLab as like version 1.2 or something. So this entire history is maintained by GitLab and we don't have to do anything. We just keep pushing the changes. And whenever there is a change, we push it to GitLab. Automatically a new version gets created and we have the complete trackability. We'll be able to track, let's say this happened for 1 year, 365 days. At any point of time, let's say if there is a major config change, we should be able to trace it from GitLab history, go back to that date, extract that config, which was before that major change. Like suppose something has gone wrong in this, right? The impact is not immediate, but let's say it has occurred. We'll be able to go back to the time before this change was made, take that config and be able to use it as a gold copy. So that is one of the, those are like some of the few advantages of how our worlds are being brought together. Any questions so far? I know I've covered a lot of stuff which are still like kind of new to some of you, but Any questions? Okay.
It was just a general thing, we'll be covering each and every topic in that.
Yeah. I just try to give a bird's eye view of like where we are going.
So is it like, do we have to, store the backups only on GitLab? Because, banking customers won't like that. And even we have a solution for this, like called HPNA, Hewlett Packard Network Automation. So we have been backing up our devices for like at least for 5 years using the same method that you mentioned. We take
GitLab is one of the examples I said. So there are many version control systems. So as long as you have a way to trace back your versioning and be in a position to go back to any previous config which you want, it's very much fine. Right? It's not, GitLab is one of the options. And banking systems also, they can have their own implementation of GitLab. When we say GitLab or GitHub, we remember the public repositories, right? So public repository is one thing, but each company can have their own implementation of GitHub or GitLab, either on cloud or on premise.
Okay.
So it is still fine. Like banking customers can still have secure way of storing the things.
All right.
Yeah. And since GitLab and GitHub are so popular, whenever I'll be referring to version controls, I'll be using these. But your organizations can have their own version control system. Okay. Now that I've stressed upon why you guys need to start getting into the development kind of mindset, the first thing that we'll be requiring is something called as a development environment, right? Just like how we have network environment, as network engineers, either EVE-NG or GNS3 is our go-to choice for playing around with the virtual devices, and then our real devices come into picture. Just like that, the developers will have their own this thing. So they have a system, either a Ubuntu machine server or a Windows machine, where they have all their tools installed, like IDEs, integrated development environments, API testing tools, Java, programming languages, etc., etc. Right? So that's what we mean by development environment, a machine with all the pieces which are installed. Right? Development environment is nothing but a collection of software tools and resources which will help us to do our job. So typically it can be local, it can be hosted, or it can be cloud-based. Right? Local means we have it on our own system, and hosted means yes, we are borrowing it from some hosting provider. Cloud-based is we are borrowing from AWS or Azure or Google. Right? Typically, these are some of the things like Python, Docker, Postman for use for APIs, Linux, this is Java, Node.js, React, and so on. Okay, this is about OSS. This is the version control system that I spoke about. Right now, like multiple developers or multiple network engineers will be making some changes. So they all need to sync their work to a remote repository, right? So there is a concept of pull and push. Whenever they make some changes, they need to push that code to central repository. Next day, when they come and they want to start their work, they need to pull what are the latest changes which are there in the central repository, so that their system is in sync with the remote repository, and then they start doing their work. Okay. Then these are some of the programming languages. Now, we are getting into the basics, nuts and bolts of programming languages. Now, when we hear about programming, right, basically two terms come into picture. There's something called scripting language. There's something called as a programming language. Right? Typically, you hear Linux admins or the network admins. They always talk in terms of scripts. right? Shell script. They'll be writing shell script to achieve some tasks. You won't hear terms like I have written a code or I have written a program, right? So scripting languages are kind of low level, right? They work at a very fundamental level, at the typically to achieve OS level tasks, and they're not like general purpose, right? Which means you cannot use a scripting language, for instance, to write a kind of a game or a banking application, right? Of course, you can write some console-based games still using scripting languages, but not very high level, like say web-based games or something, or any other banking applications or insurance applications. So in that sense, they are not like general purpose. And they're typically ideal for automating simple tasks, because we don't want to spend too much time perfecting our script, right? As long as the script does its job, we are happy, right? And they're not modular or reusable. We don't focus on making it modular. Modular means breaking it down into small modules which can be reused, right? And they are usually interpreted. What do I mean by interpreted? We'll just come to a minute. But for now, I'm saying that yes, scripting languages are typically interpreted. Now, how programming languages are different are, programming languages can be both low level as well as high level. There are like low level programming languages like C, which will still give the freedom to developers to work with low level system resources. For example, in C, I can decide how much memory should be allocated to, let's say, some work that I'm doing. Right? That level of control is given by C program to the developers. Whereas there's a concept called high level languages like Java, Python, etc. In those languages, there's no, it's all automated. It's all abstracted. Memory management, for instance, is automated. The developer cannot choose how much memory should be allocated to his program and so on. And so in that sense, programming languages can be both low level as well as high level. And they are general purpose. Like I can use programming languages to write my console applications, web applications, desktop applications, mobile applications, games, scientific applications, anything that I desire. Right? Can be used to write complex applications. Support modular programming and hence can be made usable. Right? Which means I can break down my script into related components called as modules. Let's say my script deals with two different devices. One set of firewalls. First, it goes and configures some policy on a firewall, and then it comes and does something else on the router. I can break down my code into a piece, a module, which does the work on the firewall into separate, and the piece that deals with the router into a separate piece. Right? That's what I mean by modularity. Breaking down your code into related pieces is called as modularity, bringing in modularity. Now, what is the advantage? Let's say this this firewall piece, right? Currently, it is doing something in this. I'm writing one big program where I need to interact with firewalls and routers, right? So I've written these lines of code first I'll write like this. Without modularity, my code will be like this. And these three will be like firewall related statements. This will be like router related code. Right? Now, while this perfectly works, right? Any change if you have to make, right? We need to first go and see, okay, what is this statement doing and so on. Now, one level of modularity that I can bring in is separate firewall code. When I say separate, you don't necessarily have to physically take it into different files or something. Logical separation, right? How is that logical separation achieved? There's a concept called functions, which we'll be seeing later. Right? So logically, I separate my code into modules. right? So now my single code has been broken into modules. What is the advantage? Let's say this code. Now currently this firewall related code is working as part of this program. Let's say I want to tomorrow I want to do something with firewalls and switches, right? I can borrow this code here, right? So that is the advantage of making it modular. Can be compiled or interpreted, right? Now, programming languages, another difference between scripting and programming languages is it can be compiled or interpreted. Now, what do I mean by compiled and interpreted? Because I've been using this 2-3 times now. Basically, programs, right? Software programs are a bunch of instructions given to computer. Right. Now, these instructions can be written in 10, 10, and so on, which is what can be understood by CPU. Your CPU can only understand binary language, right? It talks only in ones and zeros. But I cannot write program in ones and zeros, correct? Which will be like highly impossible for me to write a program in ones and give those instructions in ones and zeros. So what I'll do, I'll write the program in the language I'm comfortable in. Of course, when I say language, there is there are two aspects to it. One is the language that we speak, which is English, of course. Right? English is the universal language which is used in computers. And the other language that I'm talking about is the programming language. Right? For now, it's not programming languages that. It's not the programming language that I'm talking about, it's the English. So I'll be writing my program in English statements. These are like English statements. Now these English statements, how will CPU understand? Right? Obviously, these English statements cannot be directly taken to CPU and you expect the CPU to run them. So somehow these English-like statements have to be converted into, this is called as machine language, right? Machine language kind of statements so that your CPU can understand this, right? So that is the basic problem. Now, this conversion of English-like statements into machine language can be done in 2 ways. One is by compiling. The other one is by interpreting. Right? Now, compiling, right? Typically, you can think of a music composer. In olden days, right? If you have to record a song, you need all the people here, right? You need the singer, you need the drummer, you need the string instrument guy, for wind instrument. You need all of them to be there for the recording. Each of them will play in sync and then they record it. But nowadays things have changed, right? Let's say the singer is not available. The drummer and the guys are available. Their pieces are recorded. Then the singer comes, he sings. Then the violin guy comes, he plays and goes. The guy, the sound engineer or the composer, he puts all these pieces together and makes a song, right? So compiling is something like that. We write all the instructions, give it to the compiler. Compiler goes through this like a music composer. He goes through each piece and says whether all of them are in sync or not. If someone is in sync, he throws error saying so-and-so guy was not in sync. Right? In here, the compiler says so-and-so statement, the English statement which you have written is not correct. It throws an error. This is called as compile time error. Right? Now, then we are supposed to rectify that because this guy has to come and correct his piece. We have to correct this. Then again, he starts looking from top. Now this is fine, right? An intermediary code called as byte code is generated, right? This is one level above machine code between English, your English language and your machine language. An intermediary file gets generated. This intermediary guy is then converted internally by, again, the compiler, one of the pieces of compiler, into ones and zeros, which goes and gets executed finally on the CPU. So in compiled languages, you have a intermediary file or intermediary code called as byte code, which is getting generated. And any errors which we have made here can be caught, right? And shown back to us as compile time errors, so that we'll catch the errors well before they are actually being executed. Okay, so that is one of the advantages. Obviously, because of this advantage, there is also a disadvantage. The process of compilation is slower compared to the other process that we are going to see. Of course, that's a slight disadvantage. Okay. Now, the other concept is interpreting, right? Any doubts with the compilation? You write code, give it to compiler, it generates an intermediary file, which internally, again, is after syntax errors, any errors are identified, resolved, bytecode is generated, which is then converted into machine code, which goes and gets executed.
Guys, you need to ask question. Huh? Please do ask question. Don't hesitate. Okay. Please, if you don't understand, no problem. We'll explain you again.
Now, interpreter, as the name suggests, right? Xi Jinping and Modi. Right? Xi Jinping knows only Chinese, Modi knows only English or Hindi. Now they want to talk. So you need a guy in between. Right? Xi Jinping says one line, "Hi, how are you?" Right? Then this guy translates into English or Hindi. Of course, this guy says in Chinese. Right? He translates it into English or Hindi. Then this guy responds. So this guy again immediately translated it into Chinese. So interpretation has to happen line by line. And because they are conversing, they are talking to each other. It's not like, yeah, this guy says 10 sentences at a time, and then this guy will convert everything and gives him. Right? Because first sentence could be, let's say, wishing. Second sentence, he is asking a question. Based on the answer, he has to ask a third statement. Right? So the interpretation has to be kind of line by line. So that's precisely how interpreters also work in case of this thing. We write a code, we give it to interpreter. Interpreter takes one line, converts it into whatever it does. Internally, it converts it into bytecode, goes and executes on the CPU. Then it takes the second line, converts it into machine code internally, machine language, and executes it. Suppose there is an error here, right? That error will be, suppose there is an error here, that error will be thrown here. These are called as runtime errors. And because there is no chance for this error to be caught before itself, right? Unless you're so well versed with the programming that, yeah, you just read this program and then you'll be able to point out, yeah, there's an error there. And this can be caught only after executing. And these are called as runtime errors. So that's the difference between compile time errors and runtime errors. So this is how interpretation happens. Now, Python is an interpreted language. We call it as an interpreted language. Python is an interpreted language. Now, maybe a couple of years down the line, you're so well versed in Python, right? You'll come back and scold me saying, you lied to me, saying Python is an interpreted language, right? So for all practical purposes, Python is an interpreted language, but internally it also works like a compiled language. So that is called as a JIT, just-in-time compiling. So there is this happens in most of the languages. Even we say Java is a compiled language. If you have any your friends who are into Java development, you ask them whether Java is interpreted or the compiled language, they'll say it is a compiled language, right? But in the process of compilation also, internally there's an interpreter. In interpreted languages like JavaScript and Python, there is a compiler, right? There's a small guy hidden who does this job of compiling. Of course, he doesn't create a separate artifact, which is, say, the intermediary artifact. So from that point of view, we call it as a Python, for all practical purposes, is an interpreted language, because the minor process of compilation happens internally. It's not visible to the end users. So mainly from the end user's point of view, it is not a compiled language, it is interpreted language. Internally, how it is managed, we don't have to worry unless we are planning to become a very advanced Python developers. Okay. So why this is important? Why no, we need to worry about whether it is a compiled language, whether it's an interpreted language? Simply because interpreted languages make our life simple by giving us something called as a CLI mode of execution, right? Because we are so much used to having a shell script, giving a command like pwd, show me the present working directory, and then it shows what is your present directory. And then based on the current working directory I am in, I issue my second command. I want to see, I know which directory I'm in. Now I want to see the files in this directory. It shows me. Then once I know that, which are the files which are in this directory, I give my next command, vi test1.sh, test.sh. So like this, this is CLI mode of execution, right? First you give one command. Based on its output, you give the second command. Based on its output, you give the third command. So you see, from that point of view, interpretation is ideal for this scripting kind of languages or CLI-based execution of languages. You guys agree with me?
You can show an example in Python.
Yes.
Yeah, I'll be sure.
Yeah.
Please ask question, guys. Don't hesitate. Please ask. Your foundation should be strong.
Because for the compiler, I need to give all these statements together. First, I'll say pwd, then I'll say ls, and then I'll say vi so-and-so file. I'll put all this in a program. It gets converted into some temporary program when it's executed. By then, it's already, I don't know what is the outcome or output of pwd, so that I can whether this is the directory which I want to do ls on, and whether this the file which I want to vi, whether it's present in this directory, I don't know, right? So this is not very suitable for our style of work. Right? Now Python, right? Python supports both, right? In Python, okay, hope I'm not jumping the gun. Yeah. Okay, so that is the basic difference between compiled and interpreted languages. Okay, now what is program? We spoke about a little bit about programming languages. What are programs all about? Right? So if I want to define, a program is nothing but a set of instructions which we are giving it to the computer. And these instructions are known as statements. In programming language terminology, they are called as statements. Right? Each line of program that you write is a statement which gets executed. Now, what exactly you are doing when you write a program and when you are executing it? You are processing something called as data. Right? Now you have a banking application where a customer logs in, he transfers certain amount from his account to some other account. What has he done? He manipulated the data, right? He went to his account. What is the data which is involved here? Banking application, money transfer. Right? There's an account 1 which is involved, account 2 which is involved, right? Now, account 1 is source account, account 2 is destination account. From source account, money is being put into destination account. Now, there's also money which is involved, right? How much money? So the data is, so what exactly happened in the process of money transfer? A data, right, is being manipulated. Certain amount of money is being deducted from this account and it is being added to this account, right? Account number, account 1 number is the piece of data. Account 2 number is another piece of data. The amount is another piece of data. So ultimately, whenever you are working with applications, what you're doing, you're processing data, you're manipulating data, correct? So your program is nothing but, you guys can hear me? It says my internet connection is not stable.
Yeah, we lost you for some time.
Okay, sorry about that. Okay, so a program, now for this program, the program which does the money transfer, what is the information that you need to give? You need to give account number 1, which is the source account, account number 2, which is the destination account, and you also need to tell how much amount to transfer. So this is kind of raw data, right? The program executes it and then it processes this data. It processes the data, okay, and then gives you a message saying so and so amount has been transferred from this account to this account, right? So a program is nothing but it is manipulating the raw data and converting raw data into a processed information, right? Let's say you have generated a router configuration. You have taken a backup of router configuration. Now you can write a program to read this configuration, extract useful information, like what are the interfaces which are configured in it, how many interfaces are, what are the IP, what is the management IP address, and so on, right? You can, your basic configuration, the running configuration becomes the raw data. I can write a program to extract useful information from this raw data and display in a nice form, right? So that is nothing but programming. A program takes raw data, works on it, converts it into a processed thing. That's what we'll be doing. As you're going to see, we are going to do most of the times. That's what we'll be doing. We'll be writing some set of instructions to process raw data into desired output format. Okay. If no questions there, we can jump into the topic of the day, Python.
Any questions? Guys, come on, any questions? Yes or no?
No.
Okay.
No. Yeah. Thanks.
Is this script fine or do I need to zoom it? This should be fine, right? Okay. Okay, so now that we know we have to learn some or other programming language, we decided to go with Python, right? For various reasons. One of the reasons most of them tell is Python is very easy. It's almost English-like, right? In the initial stages, yes, it is, but some people disagree. They find Python also it's people who, especially if they have tried a couple of other programming languages, they say it's as complex as other programming languages. Right? So yeah, I mean, let's let them tell what they tell. But yes, why we are learning Python is because it's huge popularity, because of its huge popularity, and because has put a lot of money behind Python. Right? Cisco has chosen Python as their programming language of choice, and they started putting Python on many of their network devices. So we are forced to learn Python. Okay. Now Python is this statement will bring all the concepts that I discussed together. Of course, there's an additional concept which I'll be talking about. Right. Python is an interpreted, object-oriented, high-level scripting language used for general-purpose programming. Right? So this one statement tells a lot about Python. It's a scripting languages as well as a programming language. You can do scripting as well as programming with that. It is low-level as well as high-level. It is general purpose, it is interpreted, and there is also something called as object-oriented. What is this object-oriented? Briefly tell you, writing program with real-life objects in mind. Now, the banking application that I spoke about, we have two accounts. We have some money which is going from one account to the other account. In object-oriented programming, I treat each of these accounts as an object. Account 1 is an object. Account 2 is an object. Right? From this, when we say an object, right, in real life objects like pen or table or a bike, right, there's a state and there's a behavior. For the objects, there is a state, there is a behavior. For example, bike is in a static state. Like as long as it is standing, it is in a static state. We can start the bike, we can take it to speeds like 50, 60, 100. So it's in motion. So same way, bank account has a state. For example, like bank account is active, it has certain amount of money inside it. So this defines its state. The state, the account number, the status of the account, whether it is active, inactive, what is the amount in it, that defines the state. Behavior is you can take out money from it, withdraw it, you can put money into it, you can transfer money from this account to some other account. So that is the behavior. So in this sense, we develop programs by treating each of these as objects with certain state and behavior. We through the behavior, we modify the state of these objects. So in the previous example, if you had to treat this as an object, this as an object, in the before this this behavior of transferring money has taken place, this account had, let's say, 5,000 USD in that, and let's say I've transferred 1,000 USD into this account. Now this account is left with 4,000 USD. Let's say this account had another 5,000 USD. Now this account is left with 6,000 USD. Okay, so from that point of view, like we can treat them as objects whose state has been modified via this behavior of money transfer. Right? Extending this concept to networking, we can treat, this is router 1, this is switch 1. I can treat this router 1 as a logical object. As well as this switch, right? I can treat each of these devices as logical objects. When I say this is a logical object, we are saying there is a state. Whenever I say object, there's a state and behavior associated with it. Now, what is the state of this router? Its current configuration. current config. What is the behavior? Whatever you can do with a router, that is in behavior. Like I can add VLANs. I can add interface. I can configure interfaces, right? I can configure usernames, passwords, etc., etc. Right? Now, these are also part of the configuration. By now, the behavior can be like add VLAN. When I call this, when I invoke this behavior, the current configuration gets modified, which means now there is an additional VLAN, right? It's changed. Its state has been changed. Its state has been modified, right? So that at a very high level is object-oriented programming. By treating each of your devices as real-life objects, through the behavior, we can modify its state. Now our programming is going to be centered around objects. Okay, that is Python in short for you. Python is an interpreted, object-oriented, high-level scripting language which can be used for general-purpose programming. Now, using Python, you can build console applications, you can build games, you can build web applications, you can build scientific applications, you can build desktop applications, you name it, you can build it. Okay, it's that powerful. It's created in sometime in 1991 by a guy called Guido van Rossum. It is wide, yeah, as I just said. Right, it's a general-purpose high-level programming language to stress on that point. When we say high level, right, we don't have to worry about the the low level functions like memory management, network management, etc. All that is like abstracted. I don't have to worry how my memory is being managed when I'm writing my code. Right, I can focus on solving a business problem. Right, creating how I can configure a router, how I can configure a switch. What are the VLANs that need to be added? That's what I can focus on rather than worrying about how to give instructions to the CPU to perform such and such a task. Okay? That's what we mean by high-level programming language. The Python interpreters are available for many operating systems, including network operating. This is what I said. For on most of the network operating systems as well, you have Python interpreters being shipped by those respective vendors. So that's another very good reason for us to choose Python. If we have to learn some programming language, why not Python? Python is commonly used for this data visualization, etc., etc., etc. Yeah, this high-level programming that we have already said. It's closer to humans, which means we can write in English-like sentences, as we are going to see. When you write a high-level programming code, it's not directly compiled. It's not directly compiled on machine, but gets interpreted. Yeah. So that's what it is for us. Python is an interpreted language. A slight glimpse into how interpretation happens in Python, right? We write a source code, we pass it to this guy called as Python interpreter, right? As I said, like for all practical purposes, from end user point of view, it isn't. I don't care how it happens, right? As long as there is no intermediary code which is getting generated directly, you end up with bytecode which goes and gets executed. But you see, internally there's a compiler which generates a bytecode which goes and gets executed on some other machine called as virtual machine, Python virtual machine. But these are all internal stuff. For me, as an end user, I give source code, I get machine language, which gets, I mean, I get as in, I don't get it, it directly gets executed.
Output.
Yeah, we get the output. Okay. So the same thing what we said. There's something called as Python virtual machine. We don't really have to worry about it. Okay. Now there are so many ways you can work with Python. The first way is the natural way. Go to Google, say download Python. It gives you, if it's Windows, it gives you an executable file. If it's Linux, it gives, if it's a Mac, it gives you that, whatever that format, DMG or something. File, you double click it, it gets installed. And the other way. Yeah.
Sir, show the example of it. Just open your Python. So now let's start giving the examples.
Yeah.
CMD.
Okay, it's available as an executable file or for all the OSS. I've already downloaded and installed it.
So, Ravi, sorry to interrupt. So I was about to ask this question. So what all things should we, install on our laptops, like to start, on programming?
That's what we'll be telling now.
Okay.
That what we'll be showing you live right now. This is the interactive mode. Sir, go ahead.
Sorry. So, is there any particular laptop configuration required? Like
No. It can work with very basic laptop.
We are going to show you something more better, where to practice. Okay, not this. This is the interactive mode. Okay, you have to write the code and execute. Okay.
Let me complete this section. A lot of things will be
clear. Yeah, sure. Just wait. Okay.
So as I said, like there are a lot of ways you can start getting introduced to Python. One is, as I said, like you can download, install it. And once it's installed, it automatically updates your path. So you can open your command prompt and say Python. This is called as shell, Python shell or CLI, command line interpreter. So you see, it has given an introduction, what is the version of Python, etc., etc. And then it has changed the prompt so that I can know, okay, this is not my usual DOS prompt, it is my Python prompt. So here I can start giving Python commands. Okay, so this is known as CLI mode, where our typical shell mode, shell programming mode, right? This is like as good as your BASH shell, so that you start giving your shell commands on that. Okay. Now the second thing is there is something called as Anaconda, which comes with a lot of tools, right? You can download this. It comes with advanced IDEs, etc., etc., etc. Right? So this is second option. For this, you don't need Python because this comes with Python. When you download this, this also brings Python along. Now, the third and simplified way is if you have Google account, which obviously you will have, right? All you need is your Google account. There is something called as, now these Google guys are so good. They have given one very nice environment for us. Right? There is
Google
something called as a
Google account means a Gmail account. Okay.
Yeah, a normal your Gmail account. Right? There is something called as Google Colab. Search for Google Colab. It takes you to something called as colab.research.google.com. You click on that. Obviously, just like with anything else, you need, if I've already signed in, so that's why it has taken me directly there. If I've not signed in, it would have asked me to sign into my Google account. Once I sign in to my Google account, it takes me to this, right? So this is like a Python environment, which is on the web. You don't need to install anything on your laptop. And it is linked to your Gmail account, which means whatever work you do here automatically keeps getting saved to your Google Drive, right? So what we recommend is you can start with this if you already have this thing till the time we, of course, we'll also be giving a lab guide, which will talk about how to install Python and how to start working with other modes like interactive mode, script mode, etc., etc. We can you can start your work on this. Right. So I have opened my Google. I go to File and say New Notebook. Right. Now in Python there is another concept called as interactive Python. Right. Script mode, of course, is one way of interacting, but there is one more. They have taken this level of interactivity to another level by introducing something called as interactive Python. Right. Now, in interactive Python, you see this extension IPYNB. It stands for I for interactive, PY for Python, NB for notebook. Right. So you can write your code in the form of like what I'm currently seeing is notebook with a bunch of cells, or like typical you have lines in your notebook. Right. Now, why this mode has been given is in AI community, right? People like typically people are not people who initially started using Python for getting their work done. They're not from the hardcore programming background, right? So like they are working on Python, let's say they want to keep their code as well as the documentation together. So if I write some scientific code here saying I'm building a so-and-so machine learning ML algorithm here, I want to describe what this guy is doing here itself. So I need now this is my code. What this hash means, what is all this, I'll come to that. But suppose this is my code. I want to put a description here itself. So here I'll add something called as a text cell. And here I type the following section. Like I have my documentation and my code together. And this is the concept of notebook, right? I can go on adding cells here. I can add the cells either from here or from here. I can have multiple code cells. In between, I can have a text cell. Okay. So here I can give my Python commands. Executing this, like this. So it is connecting to Google servers. Google has allocated one machine for us. It is connecting to that.
So Ravi, what is the need of multiple, these codes, these lines? So can't we use just one, section of this? And
you can, but as I said, like I want to do PWD here. Right, execute and see what is my PWD, and then do ls here. So if you want to do, if your style of working is that, and then this is which is typically the style for data scientists, data analysts, artificial networks engineers, ML engineers, right? So they write some code.
Basically, in one section, I can have multiple lines of code, right?
Yes, I can have.
Okay.
Here I can have multiple statements of code. I can write one entire program here. In the second one, I can write entire program. Okay. So these are different ways. One, either you can download and install, and then you can access via your command prompt. This is interactive mode of Python, which means I can give my shell script like commands here. And the other one is IDE, the script mode. Like I can have these are known as IDEs, integrated development environments, which means instead of like shell command line, I can put all my statements in a file and save it as .py. .py is a extension for Python files, and then execute it. Okay, so why we call this as IDE, Integrated Development Environment, is this helps you to write the code as well as execute it and debug it. It comes with a bunch of other tools, right? If you want any dependency code, third-party code to be borrowed, that can be done from here, right? So we'll be seeing all this, but everything that you need during your development process can be managed without going out of this. We call this as IDE, Integrated Development Environments. Most popular IDE for Python is PyCharm. PyCharm is available in community as well as enterprise version. Community is good enough. Community is free. Enterprise is costly. But another beautiful IDE by Microsoft guys is Visual Studio Code. Right? It's simple, super fast, very powerful, and it has become like a favorite of a lot of guys. Okay, here this also is like idea. I can write my entire code and save it in a file called as .py and execute it right out of my IDE itself. This is called as script mode of execution. You write a program mode or script mode. You write a script, save it, and then you execute the entire script. So if you're in the initial stages, right, you want to play around with it, you can use your interactive mode, either this or Google Colab. And once you say, okay, yeah, now I'm ready to move into a script mode, you can come here and do it. Or you can start doing your programming in the script mode itself. It really is up to each one's individual choice. But there are so many options are available. That's what we just...
what we suggest is to use Google first. Okay, where you get familiar, then you can jump to some other.
Okay, and which one will you be using for future demonstrations?
We'll start with Google.
We'll start with Google Colab.
Then we'll jump to VB.
Yeah.
Okay.
Or Anaconda. As the code grows big and big, large ones. You know.
Now, actually, this Anaconda. Now you saw this cells kind of this thing, right? This actually is a third-party tool called as Jupyter. Jupyter guys have created this called as Jupyter Lab. Now, Google guys have taken this idea, extended it, and they created Colab.
Sir, rename the file first.
Okay. Now, if I click this launch Jupyter Lab, right, it opens this. So this is your bare bones Jupyter Lab, which is like running on my local host because I have Anaconda installed. So if you have Anaconda installed, you still get your Jupyter this thing access. But as we said, like initially, till you get comfortable, you can directly use Colab, which is available out of box straight away, link to your Gmail account.
Yeah, hi. So just I want to know that how many months journey from CCNA to CCI DevNet?
Yeah, actually, it depends on your speed and grasping power. But we suggest minimum three months.
Okay.
3 months. But you have to give at least 3 to 4 hours dedicated every day. That's the thing. Because it's not only just there are many things there, right? There is Kubernetes, there is Terraform, there is many things are there.
Right.
So you have to learn. See, if your fundamentals are strong, then you will be able to learn quickly. That's what we think.
So whatever I do in Colab, right? I created a new file with one simple command and renamed it as intro.ipynb. It is this is my drive, so I can see that under my drive Colab notebook there's a folder called the Colab notebooks. Under that, I mean, this folder automatically gets created the moment you start. You use Colab for the first time, and whatever you created there, they keep getting saved directly in your drive. Right? You can download them, you can share it with others, and do a lot of stuff. Okay, so Python interactive mode, script mode. We'll be using Google Colab, learn the basics.
You can share your this notebook also with other guys also. We share that, you know, whatever we create, we share it with each other. Okay, what code I have written, no execution, any improvement is required. So I think basically first we'll use this and then we'll jump to the other. Okay, sir, continue, please. Let's start the first half an hour left.
Yeah. Okay, we opened Colab, we created a new file, we renamed it. Okay, now we'll jump into the programming language concepts. Right. Now, when you're writing programs, right, you'll be creating some things. Right? Something called as variables, something called as functions, something called as classes, modules, etc. And each of those need to be given a name so that you can identify them. Right? So any name that you give to something that you use in your program is known as identifier. It's just a terminology. Right? So whenever you're trying to learn any programming language, first concept is identifiers. Identifiers are the names given to anything that you create, like a variable, function, class, module. What are these? We'll be looking into it, but these are also common to any programming language. Right? Sometimes some people get confused between variable and identifier, but both are like two different things. Variable is we'll see what is a variable. Identifiers are like names. As the name identifier suggests, they are just names. Now, to give names, there are some rules that need to be followed. Right? Programming language is all about what distinguishes between Python versus C versus Java versus Scala, or any other programming language is the syntax. Right? How you write a program in Java is different from how you write a program in Python, which means there are some rules, right? Just like how we have grammar in English, these are the syntax is like grammar for your programming language, like what you can do, what you cannot do. If you are doing something, how it should be done. Right? So same way, there are some rules to be followed for choosing the names of identifiers. Right? It has to start with either capital A to Z or small a to Z or underscore. It cannot start with digit. It cannot have white spaces in it. Right? We'll create, we'll discuss what are variables, then we'll create, because what the variables that we are creating basically use this concept of identifiers. Now, every programming language has a concept called as variables. Now, I said that when we are doing programming, all we are doing is manipulating data, right? This in the money transfer application, you have two accounts. You have some money which is getting transferred. So those account numbers should be there, are the data. The amount which is getting transferred is the data. When the program is getting executed, this data should be stored somewhere, correct? because the program has to take first account number, has to check its balance, has to decide how much money to put into the other account. So this data should be stored when the program is getting executed, which means there should be some temporary locations, temporary memory locations to store this data. Those temporary memory locations which store data when the program is getting executed are called as variables. Okay, variables are temporary storage locations which store data when the program is getting executed. Why they are called variables? Because the data which is stored in them keeps varying. When I execute the money transfer code with account 1, account 2, the data which is stored in there is account 1, account 2. When I run this code with account 3, account 4, the data which is stored in these variables is account 3, account 4. So the data keeps varying, but the variable, the address location remains same. In that sense, we call it as variable. Now let's, so that is the concept of variables. Now let's create some variables and see. Let's also see the concept of rules to be followed for identifiers. Right? So I'm creating IP1. Right. What I've done here is I want to store 2 IP addresses. Right? I chose a name identifier known as IP1 to store the first IP address, chose the name IP2 to store the second IP address. These IP1, IP2 are identifiers. Right? I mean, these are variables. Right? The IP1 and IP2 are variables. The actual text IP1, IP2, which is given to these variables, are identifiers. Right? These names themselves are identifiers, but what they are pointing to are variables. This IP1 is pointing to a memory location internally where this value is stored. IP2 points to a memory location where this value is stored. Right? When I say IP1 is equal to when I save it, what exactly happens is, this is your RAM. Why is it so slow? This is your RAM, random access memory, which is nothing but a bunch of registries, memory locations. Okay. Now, this value goes and sits here. And this location, this registry is given a temporary name called as IP1. This temporary location is given a name IP2. This value comes and sits here. Okay. This is an identifier. The memory location it is pointing to is the variable. So this is the name of the variable. IP1 is the name of a variable. Okay. So you don't have to worry about identifiers now. Now, for all practical purposes, IP1, IP2 are 2 variables which are storing 2 IP addresses. How exactly they are storing? By pointing to a memory location. Now, when I do IP1 is equal to 10.0.0.3. What it does, what is stored here? 10.0.0.1. This is thrown out. What gets stored is 10.0.0.3. So in that sense, this is This is known as variable. It keeps varying. If you put some new value, it takes the amount. Okay. Now, how will I know what is stored in these variables? Python gives us a way to check them called as print function. Right? It's a function. Right? What is a function? We'll cover in later, but function is like a utility. Right? Now, this is a built-in utility. I'll say print IP1. I stored something in IP1. Now print it and show me. That's what I'm telling. So this is an instruction. This is one statement. This is my second statement. This is my third statement. I'll also add a fourth statement. Print. Right. So I stored one IP address in IP1, another IP address in IP2. Now show them back to me. Okay, it shows them back. Then I'll say IP1 is now .0.0.3 P2. Now I'll say again show them. Okay. Now what is stored in IP1 and IP2 are 3 and 4. Right? The old values are discarded. New values replace the old values. Okay. Now
show the storage ID, sir.
Yeah.
Where it is stored.
It's actually random number.
Yeah. So now this is the random number where the value is stored.
So just like how we have a print is a built-in function, which is printing some value. ID is another built-in function, which is getting the unique identifier of the memory location where this variable is stored. We won't be able to understand much, but this is like the idea of the internal memory location. Same thing we can repeat for IP2. We'll see that the values will be like. IP1 is stored at this memory location. IP2 is stored at this memory location. Now I cannot start my variable name with this one IP. This will give an error saying invalid syntax. So I have broken grammar. I have broken the rule. Okay. And this cannot start with any other special symbol. Right? This says immediately this is wrong. And the only special character which is allowed is underscore. Okay. So these are kind of rules. And I cannot have space.
So here underscore IP is the variable name?
Yes.
Okay.
Underscore IP is the new variable. IP1, IP2 are two variables. Underscore IP is the third variable. Now I cannot have space. I cannot have that. Okay. So when I want to have a descriptive name, I should use something like this. Okay. And these are case sensitive. Now, small IP1 and capital IP1 are two different variables. Okay. So the fact about variables, they can start with, they have to start with either with capital alphabet or small alphabet or underscore. They cannot start with a digit, or they can not start with any other. They cannot even contain any other special character, not only starting. I cannot have any other special character like star or hash, etc. in between variables. Only special character which is allowed is underscore. Typically, underscore is used as a separator when you want to give a very descriptive things. And they are case sensitive, which means variable a, small a, and variable capital A are two different variables. And another best practice is do not choose cryptic names to your variables. Do not choose like X, Y, Z, A, B, C. Use always descriptive names. If you're storing IP address, choose the name IP underscore address. Of course, there is some effort involved in typing, but it's worth it. Right? If you want to store age, create a variable called age. If you don't create a variable called age. Okay, that's about.
Suppose I want to configure one router for a production. So how many percentage like we can use a Python, like means 100% we can configure through the automation, or like means at least 80 or 70% we can use the Python, and rest of the manual things we need to configure, like how?
That depends. We first have to list all the things that are needed or involved in configuring that router, and then we have to see whether there are libraries, Python libraries for that, those things. What do you feel, Sir Kamlesh sir?
Yeah, sorry. What did you ask?
If you want to configure a router, can we do it 100% with Python is the question.
Yeah, 100%. Entire thing. With IP addressing, management IP, routing protocols, everything.
Okay. And do you have that?
Only thing, if you are using through Python, so you need to access the device, right? For that, on the device, you need to access is via telnet or SSH, right? So that should be configured there. Otherwise, you won't be able to, right?
Okay.
Yeah, except for the initial connectivity setup, rest all can be managed remotely.
Yeah, but yeah, we can use Postman also for that. There are some tools are there, you know, if you don't have any access, still you can do it via Postman.
Okay.
Postman is one more. Yeah, go ahead, please ask.
And do you have that lab workbook for the CCNA DevNets, like practical?
Yeah, we are doing, it's under preparation, see. We wanted to test, you guys with, so what level we can put the labs. Okay, we'll be giving you that. Don't worry. Okay. Today is the first day, so just take it cool. Understand us, you understand us, we understand you. And then we'll, start slowly, we'll go from basic to complex things. Okay.
Right. By library, Python library, do you mean like predefined functions are there in the library?
Yes. Sure. Why don't you show an example of some library?
Yeah.
Like for accessing, I thought we use netmiko, paramiko, something like that.
Yeah.
Yes. So those are those we call them as third-party libraries because someone else has written Python code to do the connectivity and issue commands. So they have taken the pain to sort out all those issues. We'll simply be importing those libraries and calling those predefined functions.
See, you have used Ansible also, right? So in Ansible, there is a Galaxy collection. Okay. Now that Galaxy collection is for, they have written for each and every vendor like Palo Alto, Juniper. You find it everything there, right?
Right.
Same thing here, the libraries for Python.
You see now here I'm in DOS mode, right? If I want to clear screen, I issue a command called CLS. Right? Now let's say I'm in Python prompt. Here CLS will not work. Right? So to give the command CLS, I should use some library which will accept DOS level commands and then execute them. Such a library is known as OS level. There's a library called as OS which knows how to handle OS level commands. So what I'll do, I'll say first import OS. Once I get OS has a function called system, which will accept system level commands. The system level command that I want to give is CLS, which will clear the screen. Now, same way, I could give all the DOS commands. It's not a DOS command. Okay, so that's in short about libraries. Libraries are like code which is written by someone else. They are borrowing and using them. We are left with say around 10 minutes. Right? We'll cover a couple of more concepts. Okay. So we discussed about data, that variables store data. Now, data is not always like, there are different types of data that we'll be working with, right? For example, account numbers, right? Typically account numbers are like not numbers, right? You cannot, though they look like numbers, like for example, 004, 001, 06, 782, right? Though account numbers look like this, we don't treat them as numbers. We treat them as characters, because we don't treat them as numbers because we will not be performing any arithmetic operations. Like you won't be adding to account numbers. You won't be subtracting something from an account number. Account number is an account number. So from that point of view, we'll be treating this something called as a string. Right? Now name. Name is nothing but collection of alphabets. Right? So these are known as strings. But let's say the age. This is a number, like the amount we debited is a number. Right? And in number also you have integer and floating point number. Right? Let's say height 6'1". 1,000 rupees 50 right? So these are strings. It's a number, specifically an integer. This is also a number, specifically floating point number. Okay, so these are the data types. Now let's define name.
So the only difference in integer and float is that float have decimal points?
Decimal, yes. Okay. Now, how do I know which type of yeah, by looking at it, I can make out, yeah, name seems to be a string, age seems to be integer, height seems to be this thing. But if you really want to check what type of information is stored in each of these variables, we can use an inbuilt function called as type, as the name suggests. Type of, it says str, type of age. Type of is float. So that is string and integer and float. Now there can
we don't need to define like that this specific thing is an integer or a string or a float. We can just give it a identifier and then put in the value and it will automatically identify like what it is.
Yes, that is because Python is dynamically typed.
Oh, cool. Yeah, I worked on Visual Basic. I had to define everything.
Yes, yes. Visual Basic is very restrictive. We have to define a lot of things. Python is kind of dynamic. So they have taken away this requirement.
Okay, cool.
Okay. Here, sir, show them the raw input type also. Just because it's just today is just a first day, from tomorrow we'll be coming into string and all other variables, types of variables, data and all, we'll be covering in detail. But now show them, sir, as we take as a raw input, for the string, for the age. Okay, because now we are just 5, 6 minutes, 10 minutes is left.
Yeah, very, very long.
Yeah.
Now, it's like there is no restriction as you asked, right? Okay, I can simply pick a variable, put some value. Depending on the type of value that I put, it automatically takes that as that specific type. Right? Now, here I've defined it as name is equal to Jordan. Here I'll say name is equal to 25. So there's nothing stopping me. Now, if I say print type of name, here it was string. Here it is string. But since I took out string and put an integer, its type changed to integer automatically. Okay? That's why we call Python as a dynamically typed language. Depending on the value which is stored in a variable, it automatically changes its type. And you see, when I said print type, it is printing class string. So internally, everything, I said Python is an object-oriented language, right? So for every thing, there is something called as a class of strings. Now, objects belong to classes, right? I'm a human being, you are a human being, like Ravi, Kamlesh, Rohan. We all belong to a class called human beings, right? My laptop, your laptop, they belong to a class called laptops. Same way, Jordan, IP address, 1, 2, they all belong to class called as strings. They are objects of strings. 25, 50, all this belong to class of integers. Right? That is, so everything in Python that you will find is an object belonging to some class. So when you declare any variable or even functions for that matter and try to print their type, you'll see that the class to which it belongs. This is just a thing that you can keep in mind when we go to the advanced stuff like object-oriented programming, which probably comes with CCIE requirements. This will play a significant role. Okay. Now, so far what we have done is we pick these variables, put values inside. We hard-coded the values inside. But let's say we want to take the input from the user, right? Like here, I've defined IP address is this. Instead, I'll ask the user, what is the IP address? So there's a way we can take input. Right? Now, where we are printing this is known as standard output or console output. So we can print something, we can output something to the console. We can also take something from the console as input. Right? Print outputs some stuff. Same way, there's a function called input, which accepts input. I'll simply say input. It's asking me, okay, input something. Okay, I input 3. It's showing, yeah, you have input 3. But what is this 3? I don't know, right? So I need to specifically tell input, ask the user to input what he should be inputting. So I'll say input with a message. Okay. This is showing the message. Enter IP address, and then it gives a place for him to input. I asked him to enter it. He entered it. It showed, but it didn't store anywhere because I simply took the input. I didn't store that input anywhere. I can store this input in a variable. So I'll say IP3 equal to input. And then I'll say after you import. Okay. Whatever I've asked him to input gets stored in this variable, and that variable is being used here.
So what if I want to input multiple IP addresses?
There's a concept called list, right? We'll be discussing that. Okay. The thing is, since this is a very primitive way of passing the data, right? There are better ways, right? Typically, when we want to pass a lot of data, obviously you don't expect the user to keep typing this data, right? There are better ways of, we'll ask the user to put everything in a file, we'll read from the file. So this console output, console input is typically used for small, short values. But there is still a way, like he can enter a lot of values, like, for example, like let's say I just list. I need to tell him how, because all he can enter is a string. Whatever he enters on the console is taken as a string, one single string. Right? I'll have to say this. Or let's say he enters, so I need to tell him, okay, run this again. List of IPs, each separated by space or some other symbol. Right? So let's say he enters 1.1.1.1 space 2.2.2.2 space 3.2.2.2. Right? Now I'll print IP underscore list. If you're just having one variable, if you want to just output one variable, right, you don't need to use the print function. You can simply put that value, it will show. But
it looks like just one value. It's with the spaces.
Yes, that's what I'm saying. So that's what I'm saying. Whatever he has entered has come as one single string separated by space. Now I need to apply some logic to split it, right? So I'll say dot split using space.
T is missing, T is missing, T is missing.
So whatever he entered, I have converted into something called as a list. So while it can be done, it is not that straightforward, because whatever he is going to enter on the console will be taken as one single string. Right? So ideal way for taking this kind of multiple input is via files. Let him put all these into a file. We'll read the data from the file. Now I've used a concept, another built-in function on the string, right? Now IP list is a string because I can check. It's saving the file. So it's basically a string. That string, am I back online?
Yes, you are.
That string is, I've taken that string, called the split function, which is an inbuilt function. Split, when you are splitting something, you should say using which character to split. One thing I can see is they are separated by space. So I'll split by space. When I split by space, it gives me something called as a list of these values.
See, one thing, today was in general. Tomorrow, we'll be seeing strings in detail. The list of operations we can do on a string, we'll be seeing that. Then we'll come to list. The list of operations we can perform on a list. Okay, where this is split, then join, and all these operations we'll see tomorrow in detail. Okay, so don't worry, it is coming up tomorrow. Okay.
Okay, so any questions on the things that we have covered so far?
No, Ravi, it was good. We are already 5 minutes over the time, so I think we're good. Yeah.
Okay.
It was good.
Okay.
Yeah.
So, yeah, so we'll be continuing tomorrow, same time, and we'll be starting with string, list, tuple 3. We'll